we've already looked at. They try and show you a different way to approach them, part of which I'll use and part of which I will discard, because I think the way that we've done them before actually works better, because you've already seen it and it's comfortable for you. So let's read this question here. A rock is thrown horizontally at 10 meters per second from the top of a cliff 122.5 meters high. How long does the rock take to reach the ground, and what is the horizontal displacement of the rock? Okay, so we looked at this question before. All right. So person standing at the top of the cliff throws a rock off the top of the cliff and it lands over here. So we treat it as if we have components acting on this rock here. Okay. The first one is the horizontal component. So that's the speed at which that rock has been thrown. And it doesn't change because nothing can slow it down except for gravity, or nothing can speed it up except for gravity. So in this case, the horizontal is 10 meters per second. And it's consistent. It's constant, so we just leave it as 10 meters per second. Now, we've talked about this as well. The amount of time it takes for that rock to hit the ground is the same amount of time as if I were to drop the rock instead of throw the rock. All right? So if I was dropping the rock, I'd have V1 is equal to 0 meters per second. My A is my acceleration of gravity. Yeah.
So if I threw a rock straight up,
Nope.
No, horizontal.
It has to go horizontally. All right, so it has to. So if you're shooting a gun,
yeah,
all right, so you shoot a gun as perfectly horizontal as you can.
Yeah.
The time it hits the ground out away from the gun is the same as if you dropped a bullet at the same time.
yeah,
All right.
what?
Now there is some air resistance, but we neglect air resistance when it comes to this,
Yeah.
because the only thing that's really affecting it is gravitational pull. All right, nothing else is slowing it down if it hasn't hit anything, except maybe some air resistance. So we neglect it. So you understand what I'm saying with that then?
Yeah.
So if I throw it straight out horizontal, that speed's going to stay the same. It doesn't change because there's nothing to hold it back, but it will speed up as it goes down. So I have V2, I have time, and I have my displacement, which is 122.5 meters. So we've done this already, right? We remember this from before. We've talked about this very question. So now I can find out what my V2 was. Let's do that first. And that's the velocity that it's going to hit the ground as if I were dropping it. Okay? So V2 squared equals V1 squared plus 2AD. So V2 is equal to the square root of 2 times 9.8 times 122.5. So what's the velocity that it's going to hit the ground at?
49.
Go ahead.
49 meters per second.
Okay. 49 meters per second. Now, the actual speed at which it's going to hit the ground, though, down here, isn't going to be 49 meters per second. It's going to be whatever 49 squared plus 10 squared is, because that's the velocity of the components. So if you needed to know that, the resultant velocity right here, I'll just designate that, would be 49 squared plus 10 squared and then the square root of it.
50.00.
Aaron, outside. Okay, so I've got that. Now I want to look, so that's what the speed at which it's going to hit the ground at. So that's including the gravitational pull and the initial velocity that I threw it with. Okay? This time right here, I've got V1, A, and D, so I need to calculate it. So D is equal to V1 delta T plus 1/2 A delta T squared. So that's 122.5 equals 0 plus 1/2 of 9.8 times T squared. So take 122.5, divide it by 4.9, and take the square root of it. And let's find out the time.
3.689.
Perfect, 3.689 seconds. All right, that's the total time that is in the air. So it's also the total time that it's moving horizontally. So could I then find, if it's moving at a constant speed, could I then find out what the distance it is from the bottom of the cliff? Yeah? Right, 36.89 meters.
How do you
Constant speed?
times?
Let's see what times it got. Okay, so the question asks you, how long does the rock take to hit the ground?
3.689.
3.689. And what was the horizontal displacement of the rock?
It says 5 seconds.
36.89.
It says 5 seconds, and that's what I got too.
Oh, yeah.
122.5
divided by 4 is 25, I think.
Yeah, it is. And the square root is 5.
Yeah.
I screwed up there.
Okay, so
No
let's go
problem,
back
good
and let's
man.
fix up what we got here. It's fine. So that's right?
Scroll all the way down to
4.9. Oh, I didn't divide by 4.5.
Okay.
Yeah.
So what did it equal?
25. Well, 25, and then the square root is 5 seconds.
Is it right on the nose?
Yeah.
5 seconds? Okay, so then this is 5 seconds here. So that works out to 50 meters. Okay, so do we remember this question at all?
Oh, no.
Yes or no? Cute old Jason.
No.
All right. The rest of you remember this question from doing it before?
No.
Okay.
I actually don't know.
Yes.
I don't
Right.
ever do this stuff.
Okay. So the biggest thing is when you go horizontally, you have to remember that it's the same as dropping it. There's the whole deal with that question. Okay. A ball is thrown from the top of a building with a horizontal velocity of 20 meters per second, hits level ground 80 meters from the face of the building. How high is the building? Okay. So same idea on this question. So my velocity is 20 meters per second, correct? And it gives me the distance it goes away of 80 meters? Yeah? So what can I find here?
Time.
Time. What's the time? 4 seconds. That was easy. Okay, so now that I know that, I've got V1 is 0, A is 9.8, my time is 4 seconds, and you need to find the displacement. Okay?
So it's similar then.
Is that equal? All right. So far, so good? Just process 1 sec. Let's see this next question. All right, any questions about that? So I was just working. Okay, all right, this next one poses a little bit of difficulty for us. Not difficulty, I shouldn't say that. This next one is again a question that we've seen. We used a balloon when we were doing this in the second unit. We used a balloon to do this. This time they're going to use a helicopter. Okay, so a helicopter is rising vertically at a uniform velocity of 14.7 meters per second. When it's 196 meters from the ground, a ball is projected from it with a horizontal velocity of 8.5 meters per second with respect to the helicopter. Calculate when the ball will reach the ground, where it will hit the ground, and what its velocity is. All right, let's just kibosh it. Let's talk about what's happening here. I've got a helicopter that's going up. Okay? So it has a velocity that is actually going up here. And then it hits 196 meters above ground, and then it throws something out of that helicopter. So it's going that way. Now, I said to you before that when we were dropping something, the initial velocity is what? Initial velocity is 0, right? I'm holding it. What's its speed right now?
0.
0. However, the helicopter is rising. So now I have to take into account the fact that if it's going up, so is whatever I'm dropping. Or in this case, throwing out the helicopter. All right? So my velocity, my vertical, when I look at this part of it right here, when I look at it right here, the vertical part, my initial velocity is going up at minus 14.7 meters per second. Now the reason I put a negative on that is because when it's dropped, the acceleration is going to increase its speed. It's going in the opposite direction of it. Okay? So you either in this question have to make the velocity 1 a negative or the a negative because they're moving against each other. So I like to just do this, put that there. Then my a is 9.8 meters per second squared. Okay? I don't need my V2. I do need my time, and I do know how high up it is. How high is it above ground when it's thrown?
196.
196 meters. Okay. All right, now I'm going to ignore the horizontal aspect of this question for a second. No, maybe not. What's the velocity it's thrown at?
8.5.
8.5 meters, okay? I need the time in order to find out the horizontal distance it went, right?
196 by 8.5.
Okay. All right, now, I'm going to use the equation that deals with these four pieces of information. So again, it's D equals V1 delta T plus 1/2 A delta T squared, right? Okay, so what I have then is I have 196 equals minus 14.7 T plus half of 9.8,
4.9.
4.9 T squared. Okay, so far?
Is the ball not going out, it's going up?
No, it's
So if you go
horizontal.
14.9.
The helicopter's moving up, but he throws it out horizontally, away from the helicopter.
So it's got momentum moving up.
Yes, it's in the helicopter right now. Okay, are we following so far? Because this is about where it's this is the confusing part. Now, we haven't done this in math yet, which we have to do. So we have done a little bit of this last year because it is factoring, and we are solving for a quadratic, so we have done some of this. So what you have to do is you have to get everything to one side and let it equal 0. So I'm going to go 0 is equal to 4.9 T squared minus 14.7 T minus 196. Okay? So again, this is all math that's new-ish to you. So all I did is move the 196 over, right? Now your numbers are going to work out nicely all the time for this question because you don't quite have the ability to solve these yet. We are getting there in math. We'll get there in applied. We'll get there in pre-calc next semester. So the numbers work out pretty nice. And what I mean is the first thing that I want to do is I want to get the coefficient out from in front of the t squared. So I'm going to divide everything by 4.9. So that's going to leave me with 0 equals t squared minus 3t minus 40. Check that. 196 divided by 4.9.
Yeah.
Okay? So at this point here then, move it down a bit. At this point here, you should be able to do this. Okay? We've done this before. Let's see. I know you probably don't remember. So we're going to do it together. I have two sets of brackets. Okay? The first bracket are the factors of t squared.
T and T.
T and t.
All this stuff.
Something like that. All right.
Yeah.
What are the factors of negative 40 that add to give me negative 3?
Oh,
8 and 5?
Negative 8, like one negative and one negative.
Yeah, negative 8 and plus 5. Okay? Negative 8 times 5 is negative 40. When you add them together, you get negative 3. Right? So therefore,
Are taking a long time.
t equals 8 or negative 5. Can I have a negative time? No. So how long does it take for that object to hit the ground then? 8 seconds.
How come the 8's positive and 5's negative and it's not the other way around?
What do I subtract 8 from 8 to get 0? T subtract 8 has to give me 0. So what does T have to be? 8. Correct.
We're not allowed to graph it, we got a back here.
No, I don't care if you graph it. Yeah, that's a good point. You could have graphed this on Desmos and got your zeros too. That's all. That also works for you, and that's a good point. I would use that actually instead of
It just takes a long time.
well,
I don't know how to do
Which
that.
one did you put into decimal?
Man,
Oh,
like
you
last time I was
you're gonna put this in right here, and instead of 0, you could put y. It would still graph it as 0, but I would put y in equals that equation, and then you would find out where the zeros are.
Would you put X for T?
Yes.
Oh.
Oh, I would have put T. Good question.
Well,
Okay.
there's no T in Desmos.
All right. So I have this as
Oh, yeah, I guess you
8 seconds. So what's the distance it lands away from the helicopter? What'd you get?
68 meters.
68 meters. Okay.
God, that's a tough one.
What is its velocity? What will its velocity be when it hits the ground? Okay. So we still actually need the V2 from here as well then. And we have same thing, V2 squared equals. All right, so check this one out. V2 squared equals negative 14.7 squared plus 2 times 9.8 times 196. So take the square root of, punch it in like this, square root, 14.7 squared plus 2 times 9.8 times 196, close your bracket and hit equals.
63.7.
And there's the velocity that it's going to hit the ground at. That again is the vertical velocity. All right, that's not your combined, that's the vertical component. So now what you would have to do is calculate this one right here. So this is 8.5 meters per second. This is 63.7 meters per second. Let's get that velocity right there. Okay?
$64.265.
Perfect. 46.64. Point
265.
265 meters per second. Right on.
You're 63.7. Because it's changing, do you have to find like the average of it? Like, because it's not a constant speed all the way down.
No, but we're factoring in acceleration. Okay, any questions? Rock? Any questions here?
What?
What makes it a lot is this part right here.
Yeah.
Otherwise, all that work up here. is
Well, we already
exact-
did that.
We already did that stuff.
It's just,
For
Just
structure.
forget how to do that stuff.
And that's what I expect that you haven't done it. Okay, so that gives you 7 questions on 174, 175. And you should have been pretty much done the 166 questions. If you're not, you're a little ways behind. So finish up page 166. You got 174 and 175 to do. And that's today's assignment. Okay? Anybody have issues with page 166? Just have a look back at your work. I'm sure you asked on Thursday, but you...
Oh, on 166, number 4,
Mm-hmm.
the girl pushing on the shovel.
Yeah.
So
Should we just
Yeah. the force applied is 100 newtons.
Yeah.
Right? It's like the hypotenuse. The bottom leg, like
Mm-hmm.
adjacent to the ground,
Yes.
is that your F net?
No, it's your FA.
Isn't your FA the hypotenuse?
No. Your applied force is in the direction of the motion. So when you're pushing a shovel, you're going to be moving horizontally. That's your applied force. It doesn't change whether you're pulling or you're pushing, Austin. Whether you're pushing a lawnmower or pulling a wagon, doesn't matter. That's a force right here. But the direction of motion is that. If you're pushing a lawnmower, therefore, that's your applied force right here. All right?
so.
And if it says a uniform velocity, then that means that your applied force and your force of friction have to equal each other. All right? And your normal force, if there's no mass given here, your normal force is the force at which you push down on the ground. That's all the pressure that the ground pushes back up on it, unless they give you a mass of that, and then you would add it on to it. Okay?
Thank you.
Well, anybody else from that page?
The force applied is the bottom.
Okay.
The force applied is the bottom.
So this is all 5 for 1 unit.
No, because the Newton's laws kind of leads into it, right? But they kind of, basically this is a combination of Newton's laws and Unit 2's projectile. Same matter, smart.
You said like a whole bunch of
So the only new stuff in this whole section is actually the force of friction coefficient. That's the only thing that's new, but you haven't seen already.
We're trying to find a code. Or
Coefficient or coefficient?
Yeah, genetic friction or whatever.
Yeah.
Do we